K0 plus delta K. Here K0 is equal to omega over C times NO. Okay. The O means the original N. Okay. So this becomes omega T minus omega over C times original N. If you use KDP crystal, the original N is the ordinary refracting index. Minus 1/2 NO cubed times R63 times EZ. EZ is equal to EM sine omega MT. Okay, so the output beam has the electric field equal to this times D, here times D. This value at this surface, You observe that this part, this minus omega C, omega over C times NO times D, this part is a constant value independent of time. Okay, so if our interest is not the space phase, if we are interested in the time phase, the phase in time, so we can ignore this part and write E out as A cosine omega T plus delta sine omega NT. Here delta means the product of this constant times this constant times D. Okay, here delta means delta is equal to omega over C times this. Okay, so you can write this as this. However, you know that omega over C is equal to 2 pi over lambda. Okay, here lambda is wavelength light wavelengths in vacuum. Okay, so you can substitute omega over C as 2 pi over lambda to get another expression, pi NO cubed 63 times E M times D over lambda. Okay, so you will have this delta. This delta has a name called phase modulation index. Okay, this constant delta is called phase modulation index. This is not refractive index. It is some kind of constant called phase modulation index. The magnitude of delta determine the amplitude of the modulation. Okay. So now we have this form of output field after modulation. Okay. Without this term, we have cosine omega t. So we know it is a periodic variation with respect to time. However, now we have another frequency, omega m. So the final result is not really periodic result because omega and omega m may have different period. Okay. We now want to show you that this can be rewritten as a sum with infinite many of different frequency components. Okay. 就说这可以写成一个有无穷多种频率的项的和。那这个无穷多项长成什么样子呢？ We have a frequency omega. We have this component, and we have omega plus omega m. Omega. We have the term corresponding to frequency omega plus omega m. Omega minus omega m. And we also have term with frequency omega plus 2 omega m. And omega minus 2 omega m, etc. 我们会有很多这样不同的项。那当然这一项最大的This term has the largest amplitude with some side bands having the frequency omega plus omega, omega minus omega n, omega plus 2 omega n, omega minus 2 omega n, etc. Okay. How to understand this? We need some mathematical formula. We need the so-called generating function of Basel functions. In engineering mathematics, you may have learned something called Basel functions. Okay. The solution of Basel equation be denoted for the integer parameter Basel functions. Say this y double prime plus 1 over x, y prime plus y minus is equal to 0, then the solution the so-called Basel function, the solution, it contains two possibilities. The first is called Jn x. The other is called Yn x. Some books use another notation, say Nn x. Okay. So this kind of the first kind of Basel solution, Basel function, all Jn function